Hello students, welcome back to Algebra 2. Today we're going to talk about modeling with quadratic formula. And so in order to do that, I wanted to talk a little bit about the formula for objects in motion. So an object in motion that's being affected by gravity follows this model. We've got height as a function of time is equal to -1/2 times the force of gravity times time squared plus the initial velocity times time plus the initial height. Now, gravity is constant on the planet Earth, and so as long as we are talking about gravity on the planet Earth, we will talk about this being either 32 feet per second, or if we're using metric, it would be 9.8 meters per second. So for this lesson, we will use 32 feet per second. We will keep it in feet. So that means the formula can be simplified to -16t squared plus initial velocity times time plus the initial height. Now, a quick note about initial velocity. If the initial velocity is positive, that means that whatever object we were talking about was thrown up. If the initial velocity is 0, that means it was dropped without any additional force going either up or down. If it's negative, that means that it was thrown down. Now, let's look at an example. So a juggler tosses a ball in the air. The ball leaves the juggler's hand 4 feet above the ground and has an initial velocity of 30 feet per second. The juggler catches the ball when it falls back to a height of 3 feet. How long is the ball in the air? Okay, so again, let's just write down that formula. Height as a function of time is equal to -16t squared plus initial velocity times t plus initial height. Well, I see right here that it is starting at 4 feet above, so that would be the initial height. Initial velocity of 30 feet per second, that's going to be initial velocity. And then it says we're going to catch the ball when it reaches 3 feet. So that means that's the ending height, which would be h of t. How long is the ball in the air? I want to know what is t. So plugging in these values, I would get h of t, that's the height that I'm looking for, is 3 feet equals -16t squared plus the initial velocity of 30 feet per second. It's thrown up, so it's positive, plus the initial height of 4 feet. Now I have a nice quadratic equation here. So in order to solve this, I need to have it set equal to 0. So I'm just going to subtract 3 on both sides. I'm going to move the quadratic term to the left just because that's how I like it organized. -16t squared plus 30t plus 1 is equal to 0. Now I can see that this is a prime example of when I should use the quadratic formula. A equals -16, B equals 30, and C is equal to 1. So x equals -b plus or minus the square root of b squared minus 4ac all over 2a. Plugging those values in, I get -30 plus or minus the square root of 30 squared minus 4 times -16 times 1 all over 2 times -16. All right, let's look at the discriminant. So at this point, I can use a calculator here. So let's say we've got 30 Actually, let's put that all inside the square root. Let's do this all in one shot. Square root of 30 squared minus 4 times negative 16 times 1 is equal to 31.048. Now, we ended up with a positive number, so that means that we will have two real solutions. So I've got negative 30 plus or minus 31.048 over negative 32. Now, I'm going to split this, and that means I'm going to calculate it as negative 30 plus 31.048 divided by negative 32. That gives me an answer of negative 0.327 or I can go back here and I can just change this to a negative. $1.9078. Now, the question was, if the juggler throws the ball, how long is the ball in the air? So looking at these two solutions, we have something weird going on here. Either 1.9078 seconds or negative 0.0327 seconds. Now, this is weird because that means that the ball would have been in the air for negative seconds, which this is a real world problem. You can't be in the air for negative seconds, so that means that's not correct. So that means this one right here is the correct answer. We would answer in words. The ball is in the air for 1.9078 seconds.